All right, if you've been anywhere near the software world lately, you've heard the name Docker. It's one of those tools that has totally, and I mean totally, changed the game for how we build and run our software. But what is it, really? Let's cut through the noise. We're going to break down what Docker is, the huge problems it solves, and how it all actually works.
Ah yes, the 5 most dreaded words in all of software development. Every developer has said it, and every tech lead has heard it. It's that classic, hair-pulling moment when the code that was working perfectly for you suddenly just breaks on someone else's computer or on the server. Well, solving that exact problem is the entire reason Docker was created. And this really shows you the before and after. The old way was, let's be honest, kinda chaotic. You had these long, complicated setup documents, different software versions clashing with each other, and deployments that felt like a roll of the dice. The new way, the Docker way, is all about consistency. It replaces all that mess with a single simple command that builds a perfect, isolated little world for your app that just works every single time, anywhere.
So how in the world does Docker pull this off? Well, the magic behind it all is a technology called containers. And probably the easiest way to wrap your head around what a container is to compare it to something you might already know, a virtual machine or a VM. Let's see how they stack up.
Okay, so a virtual machine is basically like having a whole separate computer running inside your main computer. It has to pretend to be real hardware, a fake CPU, fake memory, fake storage, and then it runs its own complete copy of an operating system on top of all that. It's powerful for sure, but it is also incredibly heavy. We're talking gigabytes in size, and they can take several minutes just to boot up.
A container, on the other hand, is so much smarter about it. Instead of faking the hardware, it just shares the operating system of the machine it's running on. So think of it this way. A VM is like a whole separate house with its own foundation and everything. Containers are more like apartments in a big building. They all share the same main foundation, the host's OS, but each one is its own secure, private space. This means all they need to pack inside is your app and what it needs to run. That's it.
And when you put them side by side, the difference is just staggering. Look at this. A VM is measured in gigabytes. A container is in megabytes. A VM takes minutes to start. A container starts in milliseconds. It's not even a contest. Because they have such low overhead, they're just ridiculously, unbelievably more efficient.
So we get it. Containers are fast, they're light, they're awesome. But how do we actually make one and run it? Well, it all comes down to what I like to call the Docker Trinity. It's a really simple process that takes you from a blueprint to a snapshot, and finally to your running application.
It's a great question, right? How do you actually get from just a bunch of code on a developer's computer to this reliable, running application that works everywhere? You'll be surprised at how simple and elegant the process really is.
Okay, so it all starts with something called a Dockerfile. This is just a simple text file. It's the blueprint. It has a list of instructions, like, hey, start with a basic version of Linux, install Python, copy my app's code over. Then you run one command, and Docker reads that blueprint and creates an image. Think of the image as a sealed, read-only snapshot of your app and its entire world. And finally, when you want to actually run it, you use another command to launch that image, and it springs to life as a container, the actual running piece of software.
Okay, so that's the core workflow. Now let's zoom out a little and see how this one simple process completely changes the game for modern software. This is where Docker truly delivers on its biggest promise. Write your code one time and then run it reliably, absolutely anywhere you want.
So picture this. In a modern company, the second a developer saves some new code, an automated system just kicks in. A build server grabs that code and the Docker file and automatically builds a brand new image. That fresh image then gets pushed up to a Docker registry, which is basically a private library for all your application images. And from there, it can be pulled down and run, exactly the same way on another developer's laptop, on a test server, or on thousands of servers in the cloud. It's identical everywhere. So what's the real payoff here? Well, first, it solves that works on my machine problem for good. It makes setup for new developers on a team practically instant. And maybe one of the biggest wins? No more miscommunication, because the Docker file is the documentation. It's living, breathing code that defines the environment. You get this incredible portability to run your app anywhere, and you can even run different versions of the same app right next to each other without them ever conflicting. It's a huge deal. You know, if you take away just one single thing from all this, let it be this. Docker is all about packaging software into these standard little boxes called containers that have everything they need to run. And that guarantees that your app will always run the exact same way, no matter where you put it.
And that's really the point. By taking away all the headaches of setup and deployment, Docker frees up developers and their teams to focus on a much more fun and much more important question: what amazing thing are you going to build and ship next?